All right, so let's try just using the rule to add some rational numbers. So here I'm going to add 6 over 21 plus 2 over 15. So my rule says if I don't have a common denominator, I'm going to do 6 times the denominator of the second fraction, so 6 times 15, plus 2 times 21, all over 21 times 15. All right, so you might need to do a little scratch work here. I've got 6 times 15. 6 times 5 is 30, carrier 3, so I get 90, plus 42 on the bottom. And 21 times 15, I get 5 and 10, then a 0, 1 times 1, 1 times 2, and I add those, so 5, 1, 3, so 315. So I get 132 over 315. Now you could reduce this. So 132, let's do a factor tree, is divisible by 2. I'm going to do 6 and 6, and that's 6 and 11, 2 and 3. So 132 is 2 squared times 3 times 11. 315, it ends in a 5, so it's divisible by 5. We're going to do 63 here. That's divisible by 3. I get 21, and then 3 and 7. So this is 3 squared times 5 times 7. So looking at those two numbers, they have a 3 in common, so I could cancel the 3, and I'm left with 2 squared times 11 on top over 3 times 5 times 7 on bottom. And then we should probably rewrite those. So I get 44, 15 times 7. Whoops, not 2. 7 times 5 is 35, carrier 3, so 105. So 44 over 105. All right, what about part B? I'm going to run out of room, so let me go ahead and erase. You can pause if you didn't get all this copied, and we'll look at part B. All right, so I have 1 over negative 3 plus 2 over 7. Using the rule says 1 times 7 plus 2 times negative 3 over negative 3 times 7. That's going to give me 7 plus negative 6 over negative 21. That's going to give me 1 over negative 21. And we usually pull the negative out front, so negative 1 over 21. All right. All right, let's try another one. So I have 1/4 plus 4/5 plus 2/3. So let's do what's in parentheses first. Again, we're just using the rule. So the rule says 1 times 5 plus 4 times 4 over 4 times 5. And I've still got plus 2/3 here. So 1 times 5 is 5, plus 16 is 21 over 20, plus 2 times 3. And we're just going to repeat the rule. So the rule says I'm going to take 21 times 3 plus 2 times 20 divided by 20 times 3. So what do I get? 63 plus 40 over 60. So 103 divided by 60. We'll just leave it like that. All right, so in this next example, we don't have numbers, we have letters. So I have 2 over x plus 6 over y. Well, I can still use the rule, right? So I'm going to take 2 times y plus 6 times x over xy. So I get 2y plus 6x divided by xy. All right, so normally in class I would say, okay, you try this last one. So I would suggest that you pause the video and try this one on your own and then come back and look at my answer. Okay, so what do we have here? If I use the rule, I'm going to do 2 times a squared x squared plus 6 times a squared x all over a squared x times a squared x squared. All right, we can clean this up a little bit. let me use another color. I have an a squared in each term, and I could factor a 2 out of each term. So if I pull 2a squared out, what remains? Well, let's actually, may as well pull everything out. We have an x in each term too, right? So 2a squared x. All that's left from the first term is an x plus, in the second term I have a 3, and that's it. All divided by, well, I'm going to not combine these. I still have a squared x times a squared x squared. Now, why did I choose not to combine these? Because now I can see I have an a squared x on top and bottom, right? So those are going to cancel. And I'm left with 2 times x plus 3 over a squared x squared. Okay, now almost every time that I have students try this one on their own, someone notices that you're pretty close to having a common denominator here. All you need to do is multiply this first fraction on top and bottom by an x. Okay, so if I were to multiply it by an x on top and bottom, that becomes 2x over a squared x squared, and now they have a common denominator. And so when I add these, I get 2x plus 6 over a squared x squared. Notice if I were to pull out the 2 here, this factors as 2 times x plus 3 on top over a squared x squared. So in this case, it really is much faster, right, just to find a common denominator. But before your students are comfortable with finding common denominators, you can always add fractions just using the rule for adding fractions. Okay, mixed numbers. A mixed number is a number that's made up of an integer and a fractional part of an integer. So mixed numbers are rational numbers, so we can always rewrite a mixed number in the form a over b. Okay, so that's what we want to try here. So 5 1/3 is what we say. What this really means is 5 plus 1/3. And if I rewrite these with common denominators, well, actually, let's just use the rule. 5 over 1 plus 1 over 3. The rule says I'm going to do 5 times 3 plus 1 over 1 times 3, which is 15 plus 1, or 16 over 3. Now, some of you may have learn to do this by looking at your whole number and your denominator and doing exactly what we just did, right? We multiplied 5 times 3, and then you add the numerator, and that's all over 3. All right, let's try it again here. So negative 3 2/5 is negative quantity 3 plus 2/5. And I can think of 3 as 3 over 1. So this is negative 3 times 5 plus 2 times 1 divided by 1 times 5, which is negative, I'm going to have 15 plus 2 on top, or 17 fifths. All right, now what if we want to go the other way? So here's an improper fraction, 25 over 4, and I want to write it as a mixed number. Well, let's think about dividing 25 by 4. 4 goes into 25 6 times with a remainder of 1. So I could think of 25 fourths as 24 plus 1 over 4, which is the same as 24 over 4 plus 1 over 4, which is 6 plus 1/4, which we write as 6 and 1/4. Okay. All right, I'm going to let you try the next problem in Canvas, and then we'll come back and talk about properties.